Hello, welcome to Train Signal. You're watching this lesson on the vMotion and storage vMotion features in vSphere. In this lesson, you'll be learning what vMotion and storage vMotion are, requirements for using them, and some tips and best practices for effectively using both features. We'll also be covering the enhanced vMotion compatibility feature, which can help eliminate CPU compatibility issues that can occur between hosts when using vMotion. vMotion is a powerful feature that allows you to quickly move an entire running virtual machine from one ESX host to another without any downtime or interruption to the virtual machine. This is also known as hot or live migration. The entire state of a virtual machine is encapsulated, and the VMFS file system allows both the source and the target ESX host to access the virtual machine files concurrently. The active memory and precise execution state of a virtual machine can then be rapidly transmitted over a high-speed network. The virtual machine retains its network identity and connections, ensuring a seamless migration process. CPU compatibility is one of the biggest headaches when dealing with vMotion because vMotion transfers the running architectural state of a VM between host systems. To ensure a successful migration, it is required that the processor of the destination host be able to execute the equivalent instructions as that of the source host. Processor speeds, cache sizes, and number of cores can vary between the source and destination hosts, but the processors must come from the same vendor, either Intel or AMD, and use compatible feature sets to be compatible with vMotion. vMotion is very handy when performing maintenance or upgrades on hosts, as you can move all the VMs off the host first and then back without any interruption to them. Here's an overview of how the vMotion process works. The first step is the migration request is made to move the virtual machine from ESX1 to ESX2. Next, the vCenter server verifies that the virtual machine is in a stable state on ESX1. Next, the vCenter server checks the compatibility of ESX2, which includes the CPU and networking, to ensure that it matches that of ESX1. Next, the virtual machine is registered on ESX2. Then the virtual machine state information, which includes memory, registers, and network connections, is copied to ESX2. Next, any additional changes are copied to a memory bitmap on ESX1. Continuing the vMotion process, the virtual machine is quiesced on ESX1, and the memory bitmap is copied to ESX2. Next, the virtual machine is started on ESX2, and all requests for the virtual machine are now directed to ESX2. Then a final copy of the virtual machine's memory is done from ESX1 to ESX2. Finally, the virtual machine is unregistered from ESX1, and then the virtual machine resumes operation on ESX2. Now we'll cover a feature called Enhanced vMotion Compatibility, which is directly related to vMotion. Enhanced vMotion Compatibility, otherwise known as EVC, is designed to further ensure compatibility between ESX hosts. EVC leverages the Intel Flex migration technology and also the AMD-V extended migration technology to present the same feature set as the baseline processors. EVC ensures that all hosts in a cluster present the same CPU feature set to every virtual machine, even if the actual CPUs differ on the host servers. Normally, the host CPU is presented to a VM with all the available CPU features, such as specific instruction sets like SSE3 and SSE4, and CPU features like no execute, NX, and execute disable, XD. Most operating systems and applications determine the set of available CPU features only once as they are starting. If the features change because the VM was moved to a different host while it is running, the application could crash when it tries to use a feature that is no longer present on the CPU of the new host. EVC allows the virtualization layer to mask or hide certain features by modifying the semantics of the CPU ID instruction and hide certain CPU ID feature bits. While this masks CPU features from the VM, it does not disable them. If an application that queries and finds a feature bit missing tries to access the feature, it will still be available to the VM. EVC ensures that all hosts in a cluster presents the same CPU feature set to every virtual machine, even if the actual CPUs differ on the host servers. However, this feature will still not allow you to migrate virtual machines from an Intel CPU host to an AMD CPU host. Intel CPUs and AMD CPUs are very different from each other, and no virtualization software supports live migration from an Intel host to an AMD host. Therefore, you should only create clusters with ESX hosts of the same processor family, or choose a single processor vendor and stick with it. EVC is very useful though if you do have hosts from different processor families from the same vendor and want to use them together in the same cluster. With the rapid pace that processors change these days, it's very easy to wind up with hosts that have slightly different CPU models inside them. Next, we'll cover what storage vmotion is. Storage vmotion allows you to migrate a running virtual machine's disk files from one data store to another on the same ESX host. The difference between vmotion and storage vmotion is that vmotion simply moves a virtual machine from one ESX host to another, but keeps the storage location of the VM the same. Storage vmotion, on the other hand, changes the storage location of the virtual machine while it is running and moves it to another data store on the same ESX host. The virtual machine's data files can be moved to any data store on the ESX host, which includes local and shared storage. Storage vmotion does more than just copy disk files from one data store to another. It can also convert thick disks to thin disks and vice versa as part of the copy process. Storage vmotion can also be used to reshrink a thin disk after it has grown and data has been deleted from it. Storage vmotion can be an invaluable tool when performing storage maintenance, as VMs can easily be moved from one storage device to another while they are running. Here's an overview of the storage vmotion process. First, a new virtual machine directory is created on the target data store. Then virtual machine data files and virtual disk files are copied to the target directory. Next, the host does a self-vmotion to the target directory. This initiates the vmotion process without moving the VM to another host. From this point, the change block tracking feature keeps track of any blocks that change during the copy process. Next, the virtual machine disk files are copied to the target directory, and then the disk blocks that have changed before the copy completed are copied to the target disk file. Finally, the source disk files and directory are deleted, and the process is complete. vmotion has some strict requirements to ensure compatibility of a virtual machine moving from one ESX host to another. First, both the source ESX host and destination ESX host must be able to access the same shared storage that the VM is located on. The shared storage can be either Fibre Channel, iSCSI, or NFS. vmotion will also work with raw device mappings as long as they are configured to work in virtual compatibility mode. ESX hosts must have a gigabit Ethernet network adapter or higher to be configured on the VM kernel vSwitch used by vmotion. Slower NICs will work, but they are not recommended. For best results, and because vmotion traffic is sent clear text, it is best to have an isolated network for vmotion traffic. ESX hosts must have processors that are able to execute the equivalent instructions of each other. Processor clock speeds, cache sizes, and number of cores can differ between ESX hosts, but they must come from the same processor vendor, either Intel or AMD, and have compatible feature sets. It is possible to override these restrictions for CPUs from the same vendor, but by doing so, it is possible to cause a virtual machine to crash due to its accessing a CPU feature or an instruction that the new ESX host does not support. vSwitch network labels, also known as port groups, must match exactly, including case, on each ESX host. A virtual machine cannot be using CPU affinity, which pins a virtual machine to run on a specific processor on an ESX host. A virtual machine cannot be connected to internal-only vSwitch, which is a vSwitch that has no physical NICs assigned to it and is like a private vSwitch on a host. Here are a few more vmotion requirements. The source and destination host must both be licensed for the vmotion feature, which is only available in the Advanced, Enterprise, and Enterprise Plus editions of vSphere. A virtual machine cannot have its virtual CD-ROM and floppy drive mapped to either a host device or a local data store ISO file. This one is a common gotcha, and you should always remember to unmap a VM CD-ROM drive after you are done using it. Here are the requirements for using the Enhanced vMotion Compatibility feature. First, all hosts in the cluster must have CPUs from the same vendor. They must have all Intel or all AMD processors. All VMs in the cluster must be either powered off or migrated out of the cluster when EVC is being enabled. All hosts in the cluster must either have hardware live migration support, which is Intel Flex Migration or AMD-V Extended Migration, or have a CPU whose baseline feature set you intend to enable for the cluster. See VMware Knowledge Base article number 1003212 for a list of supported processors. Finally, host servers must have the following enabled in their BIOS settings. For AMD systems, enabled AMD-V and No Execute, also known as NX, and for Intel systems, enable Intel VT and Execute Disable, also known as XD. Here are the requirements for storage vMotion. First, virtual machine disks must be in persistent mode or be a raw device mapping that is in virtual compatibility mode. For virtual compatibility mode RDMs, you can migrate the mapping file or convert it to a thick provision or thin provision disk during migration as long as the destination is not an NFS data store. For physical compatibility mode RDMs, you can migrate the mapping file only. The virtual machine must have no snapshots. If it does, it cannot be migrated. ESX 3.5 hosts must be licensed and configured for vMotion. ESX 4.0 and later hosts do not require vMotion configuration in order to perform migration with storage vMotion, as the features have been separated in vSphere. ESX 4.0 hosts must be licensed for storage vMotion, which is only in the Enterprise and Enterprise Plus editions. The host that the VM is running on must have access to the source and target data stores and must have enough resources available to support 2 instances of the virtual machine running at the same time. This includes available CPU and memory resources. A single host can be involved in up to 2 migrations with vMotion or storage vMotion at one time. There are not too many limitations for using these features. For vMotion, it cannot be used to move VMs on local storage to other hosts. They must be on shared storage. For EVC, since some CPU features are masked, applications that may benefit from these features will not be able to use them. And for storage vMotion, you cannot use it with VMs that have raw device mappings that are in physical compatibility mode. Configuring vMotion is fairly simple. You must first set up the VM kernel networking stack on a vSwitch, which is used for vMotion, by creating a port group on a vSwitch. This can be done by editing the vSwitch that you want to use for vMotion and clicking the Add button and selecting VM kernel. You then configure the port group properties and set the IP address for the vMotion interface. You can verify the network connectivity of the vMotion interface by using the vmkping ESX service console utility to ping the VM kernel interface of other hosts. There is no equivalent of this utility for ESXi. We'll now look at a demonstration of configuring vMotion and testing it with vmkping. Okay, we're now going to configure vMotion and then test it using the vmkping ESX service console utility. So to do that, we click Configuration, then we select the Networking section. What we want to do is add a VM kernel interface to an existing vSwitch, or you can create a new vSwitch and add it to that also. We're going to add it to this vSwitch 0. It already has a service console interface on it. We're going to add the VM kernel one as well. So we click Properties. We click the Add button down here. We want to select the VM kernel type. Now that handles all the vMotion traffic, but it also handles iSCSI and NFS traffic as well. Click Next. Give it a network label. Usually the default VM kernel is good enough. Optionally, you can give it a VLAN ID if you're using VLAN tagging on that vSwitch. And the important thing is to click this Use this port group for vMotion. Now we click Next. Now we need to give that interface an IP address. So give it an IP address. Also a subnet mask. And then you see the VM kernel default gateway down here. You can click Edit to give it that. And that is simply just whatever the default gateway is on that subnet that it's on. Click OK. Click Next. And now you can see on this vSwitch we have a VM kernel port group and a service console port group, and they have different IP addresses. That's important because you don't want to use the same IP address for both. Now we click Finish. And we click Close. And it's done. We've now added the VM kernel interface to this vSwitch. Next, we're going to test this connectivity with the vmk ping command. So what we do is open up the service console. You can do this either via pt1, which is a remote connection utility, or be in front of the server, or use an ILO board like we're using here. You log into the ESX host. Now the format for the vmk ping command is exactly the same as the regular ping command. You type the command name and the destination IP address. And this host is .213 and the destination host is .212. That's the IP address of each VM kernel interface on each host. You can see here that the command completed successfully, so we do have connectivity between both the one host and the other host. Now the vmk ping command is basically like the regular ping command, but it goes a step further. Rather than stopping at the network layer like the normal ping command does, it goes all the way to the VM kernel interface to make sure you have full connectivity from one VM kernel to the other. Now that we have successfully tested this, we can go ahead and start using vMotion. To perform a vMotion, once you have it configured on your host, select the VM and choose the Migrate option, and then select Change Host. Next, select the destination host. Once you do this, compatibility checks will be run to make sure the VM meets all the requirements to be moved to another host. If the validation checks fail, it will list the reasons why it failed. If they succeed, you will then be able to choose a vMotion priority. The default priority is to reserve CPU resources for the vMotion. If there are not sufficient CPU resources available, the vMotion will not be initiated. The other option is to perform the vMotion with the available CPU resources. This option is not recommended as it can make the vMotion process take longer, which can result in a brief period of unresponsiveness for the VM being moved while the vMotion operation is occurring. Once you select a priority and click Finish, the VM is moved to its new host. Let's now look at a demonstration of performing a vMotion. We're going to select the VM. It's on a shared data store. It's powered on. We're going to click the Migrate option. We're going to select Change Host. That's the option for a vMotion. Change Data Store would be the option for storage vMotion. So we select Change Host, select Next. We're going to select the destination now. So we expand our cluster, select our other host. It does a validation check to make sure it's compatible, that both hosts have the same configuration, so the VM is going to successfully be able to move from one to the other. That's succeeded. Click Next. Now here's where we choose a priority. We can either reserve CPU for optimal vMotion performance, and this makes sure that the vMotion process happens very quickly and doesn't get delayed. If we click the other option to perform with available CPU resources, the vMotion may be extended a little bit and delayed, which can result maybe in a little brief period of inactivity while that VM is being moved from one host to the other. So it's best to choose the top one. Click Next, and now we click Finish. Now you'll see down here that it's preparing to move the VM. It's now migrating the active state of the virtual machine. And in just a minute it should finish. And it's complete. Check the other host. It's now over there. And that's all there is to do in a vMotion.